All right, this is day 2 on lesson 2.5. I am going to record this part on solving rational equations ahead of time so that we have time to also talk about more graphing of rational functions. All right, rational equations have x's in the numerator and denominator, and just like fractional equations in the past, we can solve by multiplying all the way through by the least common denominator, as long as it is the least common denominator of all the terms in the equation. So on your worksheet there's an example. It has an x, which would be an x over 1, minus 8 over x minus 4 equals 11, or 11 over 1. So the only denominator that other than 1 is this x minus 4. So we're going to multiply each and every term by an x minus 4. So there are 3 terms to the equation. We put an x minus 4 here, here, and here. And the whole point of that was this middle term here, this x minus 4 will cancel. So we end up with an x times x minus 4 minus an 8 equals 11 times an x minus 4. We're going to go ahead and distribute. And because it's a quadratic, we need to make it equal to 0. So if we subtract 11x, negative 15x, add 44, I'll make a stupid mistake here. Negative 8 plus 44 is 36. I was going to say 32, so I would have made a mistake. All right, factors of 36 that add up to 15 would be x minus, nope, 18 and 2 don't make 15. How about 12 and 3? Yeah, because they're both going to be negative. All right, let me just cross that out right over here. X minus 12, x minus 3 would give us a negative 15 and a positive 36. So then if we set those equal, we get x to 0. We get x equals 12 or 3. Really important that you always check for extraneous solutions. The extraneous solution is going to be, you can check it by plugging it in everywhere, but it's basically going to be, the problem will be if it makes the denominator 0. Okay? Neither of these make the denominator 0. So we should be fine. If we want to double check, we'll have 12 minus 8, which when you put 12 minus 4 in the denominator will become another 8, equals 11. So 12 minus 1 is 11. That one works. If we put a 3 in, we get 3 minus 8 over 3 minus 4 would be negative 1, equals 11. 8 divided by negative 1 is negative 8. 3 minus negative 8 would be plus 8, which is 11. It checks. Generally, as long as it doesn't make the denominator 0, it should be fine. Unless you solved it wrong, in which case it's always good to check so you catch your mistake. All right, the second example you have is way more complicated because there's 3 different terms with different denominators. We have a 3 and an x minus 2. We have a 6 and an x minus 2. Now 3 goes into 6, so we need to use the least common denominator, which is going to be the 6, and the x minus 2. So I wrote it out down here, the 3 terms, showing that I multiplied each term by a 6 and an x minus 2. They took a shortcut up top and didn't write it out quite like that. So now on the first term here, the x minus 2 will cancel, but the 3 also divides into the 6 and leaves me a 2 that I need to distribute. So I end up with 2x plus 2 over there. On the second term here, the 6 cancels. I end up with a 5x and an x minus 2. I'll distribute that in a second. And on this one, the x minus 2 cancels, so I just end up with 6 times 1 or 6. All right, quickly distributing on the left or right side, sorry. And then it is a quadratic, so I need to get it equal to 0 again. See, if I subtract 2x, I'll have minus 12x. If I subtract 2 here, I'll have plus 4. And luckily that does factor. To get a 12, we're going to use 2 and 2 so that we have 10 and 2. They are both negative. So if I put it back together, it works. If I set each of those equal to 0 separately, I will get x. If I add the 2 over divide by 5, I'll get 2/5. And here I get x equals 2. Now, if I go back to the original equation, the restriction on the denominator here was that x could not equal 2. So I need to throw this one away right away because I know it'll make a 0 in the denominator. If you want to go through and check the 2/5, you certainly can. I would use probably 0.4 to check. So you'd have 1 plus 0.4 over 3 times 0.4 minus 2 equals 5 times 0.4 over 6 plus 1 over 0.4 minus 2. That's kind of a hot mess. 1.4 over negative 1.8 times 3, negative 5. I don't know. I don't think I want to be taking time to check this. 0.4 minus 2 times a 3 is negative 4.8 down there. Over here I'd have a 2, 6 plus 1 over 0.4 minus 2 be negative 1.6. Okay, so 2 divided by 6 plus 1 divided by negative 1.6. And the right-hand side gives me a crazy decimal. So the question is it the same on the left-hand side? When I do 1.4 divided by negative 4.8, it is in fact the same horrible crazy decimal, so it does check. That was kind of a lot of time wasted, but as long as it didn't make the denominator 0, you should be fine. If it's on a test or quiz, definitely should check it so you know you got it right. All right. Common denominator here is what? Well, the only denominator is m, so we just got to multiply all the way through by an m, every single term. I'm not going to take time to write it out this time. I'll do this. This one, we'd get this. M times m would be an m squared. M times this would be a plus 8m. And m times 10 would be a 10m. You certainly could have subtracted the 8 over to this side first. You get the same answer. All right, here these divide out. So I end up with a 15 minus an m squared. I'm going to go ahead and subtract this over here. Equals 2m, because then I'm actually going to move everything to that side because I don't like a coefficient of negative 1 here. So when I add the m squared to the other side, it becomes positive. I already had a plus 2m over there, and I'm going to subtract the 15, so it's minus 15. Then it factors m plus 5, m minus 3. See if that checks. If I follow that back together, I do get a 2m in the middle and a negative 15 at the back. Right. If I set those equal to 0, I have m equals negative 5 or 3. Neither of which is going to make the denominator 0, so they should both check. I'll go real fast through the check here. If I put in the negative 5, I would get negative 3 plus 5 plus 8 equals 10, which is true. If I put in the 3, I get 15 over 3 minus 3 plus 8 equals 10, which is 5 minus 3, which is 2, plus 8 equals 10. That checks as well. All right, number 2. Common denominator here is going to have both a b and a b minus 3. So I'm going to write this out. You don't have to do it this way on your homework, but sometimes students struggle with seeing this, so I'm going to write it out. Each term is being multiplied by both a b and a b minus 3. Give you a second to write that down. Now on the first term, the b minus 3's will cancel, so we'll end up with a 4b. On the second term, the b will divide out, so we have a 3 times a b minus 3 that's going to have to be distributed. And on the third term, the b minus 3 will divide out, so we end up with a negative 2b times b, or negative 2b squared. And distributing over here, so I'm going to add the 2b squared over to this side so that I can make the equation equal to 0, and I'm going to combine like terms, get 7b minus 9. Okay, now I got to figure out how to factor that, or if it factors. I might have to do quadratic on some of these. I think if we do 9 and 1 here, we'll have positive 9 minus 2 equals 7 in the middle, so I think we're in luck. So we get 2b plus 9 equals 0, or b minus 1 equals 0. So I get negative 9 halves, or 1. Neither of which make the denominator 0, so I'm going to say they both work. If you want to go back and check them, go for it. I'm just going to save us some time. If I was going to check them, I would use negative 4.5 here for this one and positive 1. Okay, maybe I'll even type it in and check it without writing it all out, because I know some of you are still behind. 4 divided by parentheses, negative 4.5 minus 3, close parenthesis, plus 3 divided by negative 4.5. So I type all that in, I get negative 1.2 on the left. On the right, if I do negative 2 times negative 4.5, close parenthesis, divided by parenthesis, negative 4.5 minus 3, close parenthesis, I get negative 1.2. So both sides came out the same. I'm going to take time to try the 1, okay? All right, number 3, common denominator this time is a little funky. If I factor the right-hand side, I get y minus 2 times y plus 2 as this denominator, which seems like that could work, except this one is backwards. So what I'm going to do before I try to solve this is I'm going to take this term and multiply it by a negative 1 on top and bottom. What will happen on the bottom, this will become a negative 2 plus y, or y minus 2. On the top, I have minus a negative 1y, which will become plus positive. So now I have 2 times y plus 2 as the first term, plus a y over y minus 2 as the second term, and a y squared plus 4 all over a y minus 2, y plus 2 as the third term. Now if I use the common, whoops, that's supposed to be a 2, sorry. If I use the common denominator as a y minus 2 and a y plus 2, I didn't leave enough room. All right, the first one, the y plus 2's will divide out, so I end up with a 2 and a y minus 2. The second one, the y minus 2's will divide out, and I end up plus y times a y plus 2. This one, both factors will divide out, and I end up with a y squared plus 4. This looks like a really nasty problem, but I think we're going to be happy because I think something's going to cancel out here. If we distribute, get 2y minus 4 plus y squared plus 2y equals y squared plus 4. Look what happens. The y squareds, if I subtract, they're just gone. So I have 4y If I subtract, well, maybe I'll add this 4 going this way. So all I have left is 4y equals 8. I get y equals 2. Anybody have little warning bells going off? If I go back and I put a 2 in here, I'd have 2 over 4. Remember it said minus y over 2 minus 2. That's a 0. Okay. If it makes the denominator 0, you have to throw it away. So y cannot equal 2 because it is not part of the domain. So this question has no solution. I know you just want to cry right now because just did all that work and it has no solution. Okay? I know. I'm sorry. But don't be surprised if one on the homework has no solution. All right, number 4, common denominator, x and x minus 3. So 60 over x minus 60 over x plus 3 equals 1. If I multiply through by both an x and an x plus 3, oh, this was a 60 here as well. Sorry, my bad. All right, the first term, the x's divide out, so I end up with a 60 times an x plus 3, which we'll distribute in a second. The second term, the x plus 3's cancel. If I had to distribute this, remember it's got to be distributed as a negative 60. Luckily, it's just a negative 60x. Over here, nothing cancels, so I end up with a 1x times an x plus 3. All right, so distributing. Now, over here, 60x minus 60x just left a 180. So if I subtract that over to the other side, because it is a quadratic, so I want it to equal 0, I get x squared plus 3x minus 180. Factors of 180. There's a lot of them. I'm thinking 15 and 12, but that's just a math teacher, crazy math teacher who knows the factors. It does factor x plus 15, x minus 12. Most of you would have taken a while to figure that out. Or you could have used quadratic. You could use quadratic program if you have it. We set each of those equal to 0. We get x equals negative 15 or x equals 12, neither one of which will make the denominator 0, so we should be good. You can take time to check those. I'll type them in real fast. We have 60 divided by negative 15 minus 60 divided by the quantity, negative 15 plus 3. And it does give 1. If you put in a 12, 60 divided by 12 minus 60 divided by the quantity, 12 plus 3. It also gives positive 1. So I checked them by typing in both in and they both work. All right. I want to try this one on your own, but this is looking a little messy because we got to use as our common denominator 4x and x plus 3. All of those. Okay? So I'm going to write it out again with plenty of room between my 3 terms. And then multiply each one by a 4x, x plus 3. Okay, I'll give you a second to finish writing that down. The x's will cancel here. Now this is messy. I have a 4 and an x plus 3 and another x plus 3. I'm going to write it like this, or not. because remember we have to FOIL this out and distribute the 4 through. So maybe I'll take a second to do that. I get x squared plus 6x plus 9 when I do 3x and 3x here. And then I'll distribute the 4 on my next step, I think. All right, back here, when we multiply all this, the x plus 3 factor will divide out. We have a 7x times a 4x, which is a 28x squared. And the only thing that divides out back here is the 4. So I have equals 23x times x plus 3. All right, time for algebra fun. Distribute. Let's see, 23 times 3 is 69, and there's an x. All right. I need to combine like terms and subtract everything over to the one side. So if I combine those, I have 32x squareds, but I'm going to subtract 23 of x squareds over there. And then I'm going to subtract 69x. Which is a negative 45x. And I just have a plus 36. Okay, so I end up with 9x squared minus 45x plus 36, which means I can divide everything out by a constant of 9. We're running out of room. Okay, let me see. Let's slide this down and do extend. Alright, when I divide everything, or I can just take out a 9 if that makes you feel better. I'll have 9x squared minus 5x plus 4. But 9 can never equal 0, so that goes away anyway. Did I divide that right? Divide by 9, divide by 9, divide by 9. I think so. X minus 4, x minus 1 would give us a minus 5 in the middle. So we get x equals 4 or 1. Got to go back to the original problem to make sure neither one of those are going to make our denominator equal to 0. The only restrictions we had were x could not equal 0 or negative 3. Neither of which were our solutions. So there are two solutions at x equals 4 and x equals 1. Alright, again, test or quiz, you should type them in and check them. I'm not going to take time to do that because I don't want this lesson to run any longer. Alright, application. This is surface area of a box with a volume of 625, where x is the length of the side of the square base. So this is x, and I'm just going to write height for a minute here. Now, the surface area of the box, if I unfold it, kind of looks like this. Anybody ever flatten out a cereal box or something? Okay. But the bottom is a square, so I didn't draw this very well. Let me try again. The bottom is a square. These going this way are all the same size. Let's see if I can do that better. Alright, mine don't look the same size, but they're better anyway. Doesn't matter where I put those flaps. But this is x by x by x by x by x, and this is the height. Well, if I were to add up the area of each one of those, the two squares are x by x or x squared, and there was two of those. These are x by h, x by h, and there's 4 of those. And that total surface area, it says, is what we're trying to figure out. The issue is we have 2 variables here, and we can't have 2 variables. So if we go up here and do the volume of our box right there is x times h, length times width times height, and they say that's 625. All right, that's disgusting, but we want the h gone, or we want the h in this equation gone, so we're going to solve for the h up here. We're going to say h is actually 625 over x squared, and then we're going to substitute it in here. So we have 2x squared plus 4x times 625 over x squared, and that's the surface area. All right, one of these x's can divide out, so we end up with a simplified expression way up here at the top of 2x squared plus 625 times 4 is 2500 over x. All right, it says write as a function of the quotient of 2 functions. In other words, we need a common denominator. So we would multiply this guy by x over x. So we'd end up with 2x squared times another x over x plus 2500 over x, which would give us 2x cubed plus 2500 all over x is an expression for the surface area. It says find the length of the side of the base with a surface area of 512.5 square inches. We're supposed to see where this surface area equals 512.5. So into y1 I'm going to put 2x cubed plus 2500 all over x, and into y2 I'm going to put 512.5, and I'm going to find the intersection point. And remember, x can't be negative because we can't have a negative dimension on our box. All right, I'm not going to take time to show this on the screen. 2x to the third plus 2500 in parentheses, and then just divided by an x. And in y2 I'm putting 512.5. I'm going to do 0 to 20 for my first x window. My y, I'm just going to go ahead and set the max at like 600 because I know I want to see where it crosses the line 512. I get 2 solutions. If I do intersection, I get an intersection at 12.5. The second intersection point is less than that, maybe 5, I don't know. I get a goofy decimal of 5.54 as the other. So find the length of the base when the surface area is 512. So the base could be 12.5 by 12.5. Or the base could be 5.54 by 5.54. So the box could be short and wide, or it could be tall and narrow. All right, and this is the same question. I'm not going to take time to do too much with this. When you type it in your calculator, you're going to graph this and see where it equals 8, and there's no restriction on whether it could be negative this time. So if I put parentheses around the top and type this, divided by the divisor in parentheses as well, and then in y2 I'm going to put equals 8. And I'm going to set my window this time like negative 20 to 20 for my x. And for my y, I'm just going to do, I just want to know where it hits 8. So I'm going to do 0 to 10. I really don't care to see a whole bunch of this graph. Right, in the window I chose, I see two solutions. One is negative. I get negative 1.594, and the other is positive. I'm just doing the intersection, and I get 10.046. Okay. I could try to widen my window to like negative 50 to 50 and make sure there isn't another intersection point, but I'm pretty sure there's not. It's approaching an oblique asymptote here, because if we divided those out, we'd have a degree 1 on the top. So it's some kind of slant asymptote. So there's a vertical asymptote and a slant asymptote. So there's a piece of the graph here and a piece down here. So the only time it's going to hit 8 is those two places. All right. So this is the assignment on solving rational equations.